Look up at the night sky. Every point of light seems small, quiet, distant. But almost every star you can see is a sun. And many of those stars have worlds of their own. For most of human history, we could only wonder whether planets existed beyond our solar system. Today, we know they do. Thousands have already been discovered. And what we have found has changed the question. Planets are not an exception. They appear to be a natural part of the universe. Some orbit scorching close to their stars. Others are frozen in darkness. Some are enormous worlds of gas. Others are rocky planets, closer in size to Earth. And among the countless worlds that may exist across our galaxy, some will orbit their stars at distances where conditions could potentially allow liquid water. But a suitable world is not the same thing as a living world. And life is not the same thing as intelligence. Here on Earth, life appeared billions of years ago. Eventually, one species learned to shape its environment, to build cities, to understand electricity, to split the atom, to send machines beyond its own planet, and to search the universe for others capable of doing the same. Us. But was what happened here extraordinary? Or has the universe performed this experiment before? Perhaps many times. Somewhere around another star, did chemistry once become biology? Did biology become intelligence? Did intelligence eventually look upward? And ask the same question we are asking. We don't know. But in 1961, a young radio astronomer named Frank Drake realized that perhaps there was a way to organize the question. Not to prove that extraterrestrial civilizations existed. Not to predict where they would be found. But to ask something humanity had never seriously attempted to estimate before. How many technological civilizations might exist in our galaxy, right now? To explore that question, Drake wrote down a simple sequence of possibilities. Stars. Planets. Worlds capable of supporting life. Life itself. Intelligence. Technology. And time. 7 steps separating an empty galaxy from one filled with civilizations. It became one of the most famous equations in astronomy. The Drake equation. Green Bank, West Virginia. A small group of scientists gathered at the National Radio Astronomy Observatory to discuss a question that, only a generation earlier, might have belonged more comfortably in science fiction. Could humanity actually detect another intelligent civilization? Among them was a young astronomer named Frank Drake. Drake had already taken an extraordinary step. A year earlier, he had conducted Project Ozma, one of the first modern scientific attempts to listen for radio signals from intelligent life beyond Earth. For weeks, a radio telescope was pointed toward 2 nearby stars. The experiment found no confirmed extraterrestrial signal. But something important had changed. The search was no longer only philosophical. Humanity had begun to listen. And now Drake was preparing for a meeting that would bring together scientists interested in taking that search seriously. He needed a way to organize the discussion. So he began breaking one enormous question into smaller ones. How often are stars born? How many have planets? How many of those planets might support life? How often does life actually begin? Could some of that life eventually become intelligent? Could intelligence develop technology that reveals its presence? And perhaps most importantly, how long would such a civilization remain detectable? Put those questions together. And Drake had his equation. N equals R star, multiplied by a series of possibilities. The symbols may look intimidating, but the idea behind them is remarkably simple. Imagine starting with an enormous number of stars. Then begin narrowing them down. Keep the stars that have planets. From those, consider the worlds where conditions might allow life. From those, consider the worlds where life actually begins. Then those where intelligence develops. Then technology. And finally, ask how long that technological civilization remains detectable. At the end of that chain is N, the number Drake wanted to estimate. How many civilizations in the Milky Way might be detectable by us? There was just one enormous problem. In 1961, humanity didn't know most of the answers. We didn't know how common planets were. We didn't know how many Earth-like worlds existed. We had only one planet known to contain life, and only one known example of a technological civilization: our Earth. So the Drake equation could not provide humanity with a definitive number. That wasn't really its greatest achievement. Its power was something much simpler. It took perhaps one of the biggest questions humanity could ask: are we alone? And showed us what we would need to discover before we could begin answering it. And then, decades later, we started discovering some of those answers. When Frank Drake wrote his equation in 1961, there was something almost uncomfortable about it. One of its most important questions sounded simple: how many stars have planets? But there was a problem. We had never confirmed a planet around another sun-like star. Our solar system was the only planetary system we knew. Perhaps planets were everywhere. Perhaps they were extremely rare. Nobody knew. For more than 3 decades, that uncertainty remained. And then, the universe began revealing its worlds. In the 1990s, astronomers confirmed planets orbiting other stars. They became known as exoplanets, worlds beyond our solar system. At first, discoveries came slowly. Then better telescopes and new observing techniques changed everything. One world became dozens. Dozens became hundreds. Hundreds became thousands. And with every discovery, one of the great uncertainties facing Drake in 1961 became a little less mysterious. Planets were not unusual accidents surrounding a handful of fortunate stars. They were common. Our galaxy was filled with worlds. Some planetary systems looked nothing like ours. Giant planets raced around their stars in just a few days. Some worlds traveled around 2 stars. Others existed in tightly packed systems containing several planets. And among those discoveries were rocky worlds, including planets orbiting at distances where temperatures could potentially allow liquid water. None of this means those planets contain life. A planet being in the right place does not make it another Earth. And an Earth-like planet does not automatically become a living one. But something fundamental had changed. When Drake first asked how many opportunities the universe might provide for life, he had very little evidence to work with. Today, we know those opportunities are not limited to our solar system. Imagine our Milky Way from above. Hundreds of billions of stars spread across a vast spiral of light. Now imagine planets surrounding stars throughout that galaxy. World after world after world. Suddenly, the Drake equation begins to feel different. The question is no longer simply whether other worlds exist. They do. The deeper mystery begins after that. Because among all the planets humanity has discovered, there is still only one world where we know beyond doubt that life exists: Earth. And that leaves us facing perhaps the most difficult part of Drake's question. If you give the universe a planet with the right conditions, what are the chances that something begins to live? We have one example, one experiment, one result. Life appeared here. But we still don't know whether that happened because life emerges easily when conditions are right, or because Earth won an extraordinarily unlikely cosmic lottery. And even if simple life is common, there is another enormous leap ahead. On Earth, life existed for billions of years before a technological civilization appeared. So perhaps the most important unknowns in the Drake equation were never really about the stars. They were about what happens on the world surrounding them. Does life begin? Does it become complex? Does intelligence emerge? Does intelligence create technology? And if it does, how long does that civilization survive? More than 60 years after Frank Drake wrote his equation, astronomy has answered part of his question. The universe has no shortage of worlds. What we still don't know is how many of those worlds eventually produce someone capable of looking back. There is something unusual about trying to calculate the probability of intelligent life. We have almost nothing to compare ourselves with. Every living organism we have ever studied, every forest, every ocean, every bacterium, every animal, and every human being comes from the same planet, Earth. So when we ask how often life becomes intelligent, we are trying to understand the universe using a sample size of 1. But there is another way to approach the question. Instead of asking, how likely is another technological civilization? Ask the question backwards. How unlikely would intelligent life have to be for humanity to be the only technological civilization the universe has ever produced? In 2016, astrophysicists Adam Frank and Woodruff Sullivan explored exactly this question. They used what modern astronomy had learned about stars and planets to reconsider part of the Drake equation. But they changed the question. They were not trying to calculate how many civilizations are communicating in the Milky Way today. They asked something much broader. Has another technological civilization ever existed anywhere in the observable universe? And their calculation produced a remarkable result. For humanity to be the only technological civilization ever to have appeared in the observable universe, the probability of a technological species developing on a potentially suitable planet would have to be less than roughly 1 in a trillion trillion. Think about that number. 1 trillion times another trillion. Imagine an almost unimaginable number of opportunities. And only once does intelligence develop technology, which is here on Earth. Frank and Sullivan's calculation does not prove that extraterrestrial civilizations exist. It cannot tell us where they are, cannot tell us what they look like, and it certainly cannot tell us whether any civilization exists close enough or at the right moment in cosmic history for humanity to detect it. But it changes the way we can think about the question, because if the probability of producing a technological civilization is even slightly better than that extraordinarily tiny threshold, then according to their framework, humanity would probably not be the first technological civilization the observable universe has produced. Perhaps others appeared millions of years ago, perhaps billions of years ago, perhaps some survived only briefly. Others may have endured far longer. Their planets could still exist, while every trace of their civilization has disappeared, or perhaps somewhere around another star, one exists today. We simply don't know. And this is where the Drake equation reaches the limits of what astronomy alone can tell us. We can count stars. We can discover planets. We can study distant atmospheres. But there is no telescope that can yet tell us how often chemistry becomes life, or how often life eventually becomes intelligent. Earth gives us tantalizing clues. Life appeared relatively early in our planet's history, but technological intelligence took billions of years to emerge. And even then, it happened only once, as far as we know. Was that progression inevitable? Was it incredibly fortunate? Or was it simply one path among countless others that life might take? There is another uncertainty that may be even more important: time. Imagine two technological civilizations existing in the same galaxy. One disappears a million years before the other develops radio astronomy. They both existed. They were both technological, but they never had any possibility of hearing one another. The universe is almost 14 billion years old. Human civilization has occupied only the smallest fraction of that history, and our own ability to announce our technological presence beyond Earth has existed for little more than a cosmic instant. So perhaps the greatest challenge isn't simply whether other civilizations arise. Perhaps it is whether two technological civilizations exist at the same time. That changes the question again, because a silent sky does not necessarily mean an empty universe. A civilization could be too distant, too ancient, too young, too short-lived, or separated from us by an enormous gulf of time. The Drake equation began as an attempt to estimate civilizations that might be detectable today. But more than 60 years later, it has exposed something even more profound. We have discovered that the universe contains an extraordinary number of worlds. What we have not discovered is how often those worlds produce minds capable of wondering whether anyone else is out there. And until we understand that, the most important numbers in Drake's equation remain hidden. More than 60 years have passed since Frank Drake first wrote his equation. We have discovered thousands of planets beyond our solar system. We have found worlds unlike anything we once imagined. We can study the atmospheres of planets orbiting distant stars, and our telescopes can look deeper into the universe than Drake could have dreamed possible in 1961. Yet the final answer to his equation remains unknown, not because the equation failed, but because it revealed where our knowledge ends. We know that stars are abundant. We know that planets are common. We know that some of those planets exist in places where conditions might allow liquid water. And we know something even more important. Life is possible. We are the evidence. On at least one small world orbiting an ordinary star, matter became alive. Life survived. It evolved. Eventually, intelligence appeared. And that intelligence developed technology capable of reaching beyond its own planet. It happened once. The question is whether it happened only once. Perhaps Earth represents an almost impossible chain of events, a world where everything happened exactly as it needed to. Or perhaps life is one of the things the universe does naturally when the conditions are right. We don't yet know. And that uncertainty matters, because the Drake equation is sometimes presented as though changing a few numbers can tell us how many alien civilizations exist. It cannot. Not yet. Its real importance may be something greater. It gives us a map of our ignorance. It shows us which questions astronomy has begun to answer, and which questions remain almost completely open. But there is another important distinction. Not finding another civilization is not the same as proving that none exists. Our galaxy is enormous. The Milky Way stretches roughly 100,000 light-years from one side to the other. Humanity has examined only a tiny fraction of the possibilities, and another civilization would not necessarily reveal itself in a way we expect, or at a moment when we happen to be looking. So for now, there is no scientifically confirmed detection of an extraterrestrial technological civilization. That remains the line the evidence has not yet crossed. But there is also no scientific result demonstrating that Earth is the only world where technological intelligence has ever appeared. Between those two statements lies one of the greatest unanswered questions in science. And perhaps that is why the Drake equation has survived. Not because it gave us the answer, but because every new discovery allows humanity to replace another assumption with evidence. One planet becomes thousands. Unknown worlds become worlds we can study. And questions that once belonged to philosophy slowly become questions that science can investigate. Perhaps one day, another discovery will change the equation completely. A chemical signature in a distant atmosphere. Evidence of biology elsewhere in our solar system. Or something unmistakably technological, coming from beyond Earth. If that happens, one of Drake's unknowns would suddenly become something very different. Evidence. Until then, we are left with an extraordinary situation. The universe has given us stars. It has given us planets. It has given us billions of years. And at least once, it produced us. Whether it produced anyone else remains unknown, but that leaves one final problem. Because if planets are common, if some worlds can support life, and if technological civilizations are not impossibly rare, then somewhere across the enormous history of our galaxy, others should have had the opportunity to appear. Perhaps long before us. And if that is true, there is another question we have to confront. A question so simple that it has troubled scientists for generations. Where is everybody? In the next episode, we will explore the Fermi paradox. At the Unknown Frontier Media, we don't tell you what to believe. We explore the evidence, examine the science, and invite you to draw your own conclusions. Until next time, keep looking up, because the greatest discoveries may still lie beyond our horizon.